When you get home, you copy that down. This is first page because I want to save time there. Only maybe about 20 minutes or so. Now the thing is, if you understood all the concepts of finding the first derivative and use your knowledge of equations, you shouldn't have any problem with this part. Okay, you either maximize or minimize values. That's what optimization means. Okay, maximize or minimize. It is based on the fact that the y values at the turning point, they can be a maximum or a minimum. Also, you need to equate that first derivative to 0, and then you solve for whatever variable you'll be dealing with. In most cases, it will be x. So you find the first derivative, equate to 0, solve for x. Okay, that x value can be a minimum or a maximum of that specific variable or quantity. Okay. So let's move on to examples. So the example that I'm going to do, the first one is from page 202 from the Mind Action Series textbook. Okay. All right, so you can read the question. I'm going to concentrate on the key parts in terms of me doing the question. So part A, okay, the question says find the total length of L of fencing required in terms of X and Y. Now here, okay, it depends on how you understood the question. In my case, the question says a toll road company is planning to build a picnic site along a major highway. Okay, it is to be rectangular in shape with an area of 5,000 square meters and is to be fenced off on the 3 sides that are adjacent to the highway. Let the length be x and the width be y. Now here, just to draw a small sketch, if I have a highway like that, okay, my picnic site can have a length which is along the road, which is the case which I'm gonna concentrate on, right? So the picnic site can be that one. If it's this one here, it means this will be x, okay, and obviously that's y and that's y, okay. I think it will be fair for the length to be closer to the road, that is to be along the road for various reasons. One of the reasons is that to do with space. If you're driving a car, you need more space here to come in and to go out. Okay, so I think it makes more sense for the length to be along the road. Okay, that's my opinion. You can decide your opinion. All right, so this is my case here. It means this length here is going to be x as well, because the opposite sides of the rectangle are equal. So the total length L is going to be equal to x plus 2y. Okay, the total length is going to be x plus 2y. We are not worried about this length. Okay, this one here is along the road. That's the one which is going to be used to get into the picnic site or to get out of it. And as I said, it makes sense to have a longer side being the length. Okay. All right. So that's the equation. Because they just said find the total length of L required in terms of x and y. That's your answer there. Okay. Then the next question. Now, when you are doing questions on optimization, from my past experience, some learners are nervous of these questions. I'm telling you from experience. Once they see the question on optimization, it's like the brain shuts down, right? The first part here, that area, is not grade 12. It's grade 9, 10, and 11. It's not grade 12. The second part, which is part B, is not grade 12. Okay, you are just applying your knowledge, okay, from previous grades. So B says, show that the total length of the fencing required is also given by the formula, that formula there. So let's go to the next page quickly. Right? So we are doing what? B. Okay. We are doing B now. In most cases, the questions are connected. Okay? In most cases, the questions are connected. So whatever you do in part A helps you to do part B. Okay? Part B helps you to do part C, like in this question. So if you get the first part wrong, you might get a 0 for the whole question. Okay, so I said my length is equal to x plus 2y. Okay, now the area of that rectangular site is supposed to be 5,000 square meters. So we know that area is equal to LB, but this area is 5,000, and that L there is X, the Y is B. So I'm going to use this equation together with that equation. Okay, so I have to eliminate Y for me to come up with the required equation. Now if I eliminate Y, I'll get L equal to, where there is X there, I'll put X plus 2. If I make here Y the subject, it becomes 5,000 over X. Okay? I'm sure you can see that everything I'm doing is not grade 12. It's basic knowledge of mathematics and equations from lower grades. Okay? The calculus hasn't started yet. So this becomes L equal to X plus 10,000 divided by X. Okay? Which is what you are supposed to show. Okay? That's what you're supposed to show. Okay? I'm sure you've seen, okay, you are going to see as well as I do more examples on this, or as you do your own examples, that in most cases, it's only one question which involves calculus, where you find the first derivative. The rest is grade 9, 10, and 11. So if I take part A and part B of this question into a grade 10 class, some of them can be able to do it. If I take it to a grade 11 class, some of them can do it. Grade 9 class, some of them can do it. Right? Let's move on to part C. Part C, that's where the calculus comes in. Right? Part C, right? The question says, find the least amount of fencing, which is in this case the length L. Find the least amount of fencing that will be needed to complete the job. Okay. What is the shortest length that you might need for you to fence that site? That's what the question is asking. Now, because of the word list here, okay, because of that word, or those two words, least amount, it means we are dealing with a minimum. With a minimum. We know on a cubic graph, at the minimum turning point, that's where you get the minimum value of y. So, also at that point, the first derivative is 0. So we are going to use this equation here, okay, to find the minimum length. Okay, so I'm going to move on to the next page. Right, part C. So L is equal to X plus 10,000 over X. Okay, what I'm going to do is goes back to the beginning of finding the derivative using rules. Okay, so this becomes L equal to X plus 10,000 X to the power of minus 1. Okay, using your knowledge of exponents, which is not grade 12, which is not calculus. No calculus yet, no calculus is yet. The calculus now comes when I say dl over d of x. This is where the calculus comes in. Everything else before that was not calculus. Okay? It was not calculus. So you should be able to get it right. Right? So this will give you 1, and that one there will give you minus 10,000 x to the power of minus 2. Okay? I'm not done yet. Now, because we are trying to find the minimum value of that length, we equate the first derivative to 0. So this becomes 1 minus 10,000 all over x squared is equal to 0. Okay? And then this will give me 1 equal to 10,000 over x squared. Okay? Now let me go to the next page because of space. Uh, so you end up getting x squared equal to 10,000. So your x is going to be the square root of 10,000, which in that case it will be 100. Okay. Okay. I think here we can put units because we didn't specify. Did they specify that? Let's check. Okay, that would be meters. Okay, so that's x. So this is the minimum value of x. Don't forget, it's minimum value of what? Of x. Okay, the minimum value of x. The minimum length, total length, which includes y, okay, is going to be, remember, your L is equal to x plus 2y. Okay, is it possible for us to find the value of y?
Yeah.
How?
If the area is xy or 5,000.
So we use the area. Remember, the area is equal to 5,000. It's 5,000. Okay, we know that x is going to be 100. So your y is going to be 50. Therefore, L is going to be equal to 100 plus 2 times 50, which gives you 200 meters. That's the minimum length. Okay, so for this question, the minimum amount of length of the fencing is in terms of x and y. So we need to get the minimum value for x, then the minimum value for y. Then we go back to the equation which connects the length and x and y. Okay, then you will get to that point. All right? Yes?
I didn't see the name of L as x plus 2y, so the y plus 2x.
Okay, it's a good question. You know what will happen there? In my opinion, the question also is not very fair. Okay, I talk about this part. Well, someone might have seen it as 2x plus what? Plus 2y, plus y. Okay, it's very much good to have 2x plus y. Now, if you use 2x plus y, you can try it out. You have challenges with getting that equation. You won't get that. So it means if you try to use 2x plus y, if you can't get the equation in part B, then you do the opposite. Okay, because otherwise you get stuck forever if you don't realize that you need to switch to this equation. Okay, that's why I said the question is not really fair. Or someone might view it the way that you are asking. Okay, so the equation in part B must guide you as well. Okay, the equation in part B must guide you. So you must use common sense, okay, and good reasoning. Right? Right. So that's it there. Let's move on to the next question. Right, that's the next question there. That's question 5. Okay, question 5. Alright, just before I carry on, I want you to be aware that when you are doing questions on optimization, okay, make sure you are aware that there is a connection between all the questions in most cases. So the first part The second and the last part where you use calculus is a connection. If you don't get the first part right, you're likely to have issues with the others. Okay, and you can get a 0 for that question. All right, so here we have got that shape. One is shaded, then you've got those two semicircles. If you add them, you get a full circle, right? So you can read the question there. Show that the shaded area is given by that, right? Now here, you need to determine area which is shaded. That's a rectangle. Now the length of the placement remains fixed at 100 meters. So this length here, it has to be 100 meters. Okay, this is supposed to be 100 meters. Okay, it's only the width which can change. The width can change. Okay, that's why it's labeled there as X. Right? So we're going to use your knowledge of finding the area of perimeter of a rectangle, okay, together with your knowledge of circles in terms of area and also in terms of perimeter. So here it shows that the area. So here, to get the area of the shaded part, it will be equal to the area of the rectangle minus the area of a full circle. Okay? So part A, it will be the area, in this case, with respect to x, is going to be equal to the area of the rectangle, that's LB, minus the area of the circle, that's pi r squared. Okay? Then your length is 100. Okay? Your breadth is x. Okay? Now, when you are doing these questions here, the moment you start writing the solution, like in this case here, you are given the equation. The given equation must guide you. Okay? If you see that whatever you are writing is not making sense, then you need to rethink. Okay? So here, already I've got 100x, and it's also there. You can see, which means I'm on what? On track. Okay? Then minus, I have got a minus here on the equation. Okay? I've got a minus there as well. I have pi, the pi is there, but we are going to substitute and so on. So the pi, I'll put it, okay? The radius is going to be equal to half of x, okay? Which means this will be x over 2 all squared. And then you get 100x minus, now that will give you x squared over 4. So you end up getting pi over 4x squared. Okay, just allow me to finish. So that's the first part. Okay, so I've shown it. Then the next part says determine the maximum shaded area possible. Okay, the maximum area possible. So we're going to find the first derivative, and then we need to equate it to 0 and solve for what? For x. After getting the x value, you have to substitute it into this equation to get the maximum shaded area. Remember, this equation is for the shaded part of that shade. So let me do that quickly because I'm going to take part of the break. So, part B, it's ax equal to 100x minus pi over 4x squared. Okay, so we are going to say dA of x over dx, that's 100. Remember, pi over 4 is a constant. Pi is a constant. So, this we can write as 2 pi over 4x, okay, which I can simplify as 100, that is pi over 2x. So that's my dA of x over dx. Then I need to equate that to 0, so it will be 100 equal to pi over 2x, like because of my time I'm rushing. So that gives me 200. So you get x equal to 200 over pi. That's the value of what? Of x. Okay? So then to get the area now, I need to substitute this x value into the first equation on top. Can someone do that quickly? Ax will be equal to, not of x, not ax supposed to be, A, can you do that so that we can all go? Can someone substitute?
3,183.
3,183.09.
0.09.
That should be in square meters. Okay, so that's our solution there. Okay, so the lesson stops there. Right, so I'll give you homework.